To take the derivative of an inverse trig function, we have to know the derivative of its original function. So trying to take the derivative of cosecant inverse of x, we can say let that equal y, and then we can rewrite this equation as cosecant of y is equal to x by swapping the inputs and outputs and getting rid of the inverse symbol. Now using this equation, we can take the derivative of this equation, both sides, with respect to x or y, it doesn't matter. But in this case, doing with respect to x, we get dx is equal to 1. But taking the derivative with respect to x of this function of y, we'd have to use implicit differentiation and the chain rule. So the derivative of cosecant we know is negative cosecant cotangent, but we must multiply by the derivative of the inside of the function with respect to x. So in this case, dy dx. Now we have dy dx is equal to, well, we can solve for dy dx by dividing both sides of this equation by negative cosecant of y cotangent, so we get this. But again, what is cosecant of y? Well, we said that it's x, so we can write it like this. And cotangent of y, what is that? Well, knowing this identity, we can solve for cotangent and get the square root of cosecant squared minus 1. But again, cosecant of y is equal to x, so we can rewrite it as the square root of x squared minus 1. So finally, we get the answer. The derivative of inverse cosecant of x is equal to negative 1 divided by the absolute value of x times the square root of x squared minus 1. We can also do this by differentiating with respect to y instead, and we don't have to use implicit differentiation in this case. So differentiating cosecant of y with respect to y, we get negative cosecant of y cotangent of y, and then the derivative of x with respect to y. So we just get dx dy. But we don't want dx dy, we want dy dx. But before we flip it, notice cosecant of y is x. And what is cotangent of y? Well, cotangent of y we figured out is the square root of cosecant squared of y minus 1. And of course, cosecant of y is x. So we can just write it like this. And then reciprocating both sides of this equation, we get dy dx is equal to negative 1 divided by x times square root of x squared minus 1, just like we did over here. So we get the same answer, differentiating with respect to x or with respect to y. Another way to do this is to use the inverse function theorem for derivatives. So if we did that, setting up the equation again, we can say cosecant of y is equal to x, just like we did over here. But this rule shows that we're going to need f of y because we want to get the derivative of f prime of y. Rather, we want to find f prime of y. So if we know that f inverse of x is equal to this function here, this cosecant inverse of x, that means we know that the original function, the f of x, is equal to the original trig function, so cosecant of x. And then, of course, we can plug in a y instead of an x because of our formula. So doing so, finding the derivative f prime of y, well, again, we get the same result as before. Negative cosecant of y, cotangent of y, because that's the derivative of cosecant. And again, what is cosecant of y? Well, it's x. And what is cotangent of y? Well, using the identity again, we know that it's the square root of cosecant squared minus 1. So, of course, cosecant of y is x, as we showed here. So the result becomes this. But again, the formula says 1 divided by that result. So the derivative of this inverse function, cosecant inverse of x, is equal to negative 1 divided by the absolute value of x times the square root of x squared minus 1. So 3 different ways to get the same answer for the derivative of cosecant inverse of x.